We will attempt together to estimate the square root of a non-perfect square. And we are going to do the normal division method with increasing accuracy. Now, to give a better picture about what I'm talking about, let's take a look at the first example, which is for us to estimate square root of 3. So let's do that. All right, let's just do our regular division method. 3. So what would be the divisor then? It should be 1. Because it could not be 2, because 2 squared is 4. It's already more than 3. So it is 1. So 1 times 1 is equal to 1. And the remainder is 3 minus 1, which is 2. So that's how far we can get. So that is our first estimate, which is square root of 3 about equal to 1. So square root of 3 is roughly equal to 1. And this is way from being accurate because 1 squared is equal to 1. It's really far from the value 3. Let's just tabulate our result. Our estimate, and what is the estimate squared? The first result is square root of 3 roughly equal to 1. So 1 squared is equal to 1. Let's try to improve our estimation by finding square root of 3.00. So let's find square root of 3.00 by adding 2 decimal places. Remember that if you want to find the square root of a decimal number, we need to have an even number of digits after the decimal point. So 3.00. This is our first pair after decimal point, and this one before decimal point. So the first divisor is going to be 1 and quotient 1, which results in 1 with remainder 2. When bring down 0, 0. So 1 plus 1 is equal to 2, 2 point something. And we want to estimate the next digit. The next digit would be 7. Let's calculate what is 2.7 times 0.7. 2.7 times 0.7, that is equal to 9, 4, 14, 18. And this is 2 decimal places. That means the answer is 1.89. 1.89. So the remainder is going to be 0.11. The quotient is 1.7. So the result that we have got here, the better estimation is 1.7. And let's update our results here. Square root of 3.00 roughly equal to 1.7. And what is 1.7 squared? 1.7 squared is 2.89. Alright, so we have improved our accuracy greatly by adding 2 zeros after decimal point to 3. And we are going to go a bit further by adding another 2 zeros behind it. So next step, you're going to find out square root of 3.0000. Okay, this is going to be longer still. 3.0000. So the first divisor is 1, quotient 1. 2.00. So this is 1. So this becomes 2.7. That's the next quotient. So that results in 1.89. Okay, let's just lengthen that line, because we will do one more pair of 0 later on. I'm going to reuse this division. So the remainder is 0.11. So plus 0.7, that becomes 3.4 something. Okay, so what is the next digit? Next digit, I think is going to be 3. So let's just calculate 3.43 times 0.03. So 3 times 3 is 9. 4 times 3 is 12. 3 times 3 is 9 plus 1 become 10. How many decimal places? 1, 2, 3, 4. So 1, 2, 3, 4. So the result is 0.1029. Yes, we bring down the pair. So 0.1029. And the new remainder is 1 and then 7 0.0071. So now we have improved the accuracy even further. How do I know that? Because our remainder has dropped from 2 to become 0.11 to become 0.0071. So we are converging to the more accurate representation or the more accurate estimation of square root of 3. Remember, this is just an estimation. We are not going to get the absolute result of square root of 3. Why is that? Because square root of 3 is an irrational number. Irrational number is a decimal number with unlimited, never-ending decimal places after the decimal point. So we will be able to approach to the best or approach to the most accurate estimation of square root of 3. We will never get the absolute result of square root of 3. Alright, now let's update the table. The next estimation is 3.0000, which is estimated to be 1.73, which is better estimation. And our estimation squared, that is equal to 2.9929. As you can see, our accuracy is getting better. From 1 to become 2.89 to become 2.9929. And I want to do one more calculation. I will clear this space. And I'm adding another pair of 0 here. Alright, so this add another 0.03. That becomes 3.46 and then another digit. Let's bring down the last pair. As you can see, the number of steps in getting the more accurate result or the more one more digit after the decimal place will take an extra step each time. Alright, then what is going to be the digit after 6 here? That is going to be 2. And what is the product? 3.462 times 0.002. This is equal to 4296. Alright, so how many decimal places? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the answer is 0.006924. 0.006924. And the remainder is equal to 6710000. And so the remainder is getting ever smaller and smaller. So this is our new estimation, which is square root of 3.000000, which is stand at 1.732. So what is the square of our estimations? 1.732 squared is equal to 2.999824. Let me just delete this part over here. So that's it. Our result has become much better and better, from 1 to become 1.7, then 1.73 and 1.732. So our answer up to 3 decimal places is 1.732. 3 decimal places. So from our activity in this video, we know that we can still go on and on to find out a longer estimation, a longer decimal places with better accuracy on the estimation of square root of 3. But the number of decimal places is never ending, as I explained earlier, that square root of 3 is an irrational number with a never ending decimal places after decimal point. So we can only reach to a certain level of decimal places or a certain level of accuracy with our estimation. There is no way we can get absolute result. So we will do more in example 2.